Hello everyone, welcome back to the class of macroeconomics. In today's class, we want to continue the discussion related to Solow model. So what will be the topic that we are going to address today? We want to talk about what is the role of saving in growth. Is there any optimal level of saving rate? The second topic that we want to address is what happened to the economy if the parameter value we set up for the Solow model got changed. The third topic that we want to talk about is that we want to talk about when the economy faces a shock such that it deviates away from the steady state. How will the capital stock per capita, output per capita, consumption per capita, and investment per capita change over time? So now let's begin with today's lecture. Now we want to talk about the role of savings. When talking about the role of savings, we would like to ask the question that how saving rate affects the economic living standard. The living standard we are talking about here is the long-term living standard. Therefore, the Solow model will be able to give us an answer for this question. It turned out that we will be able to find that when the saving rate is higher, we are going to have a higher capital stock in the steady state, such that we are going to have a higher output in the steady state, and thus the living standard is higher. So what we are going to do next is that I want to show you in the Solow diagram as well as solving the Solow model numerically to illustrate this concept. So to begin with, we draw the Solow diagram. The vertical axis is output, and because the units of output, investment, consumptions are exactly the same, therefore the numbers show up in here can also equal the investment. The horizontal axis is the capital stock. That is because we know when we are looking at the Solow model, the value of the capital stock determines the value of all the other variables, which includes the output, the investment, and the consumption. So then the first line we draw on the Solow diagram is the production function. It tells us how does the output related to the capital stock. The second line we draw on the Solow diagram is the savings. Because in equilibrium, the investment equals the savings, so then we know this curve represents the actual size of the investment. The last line we draw on the Solow diagram is the steady state condition. This equation is generated from the law of motion, which tells us for an economy to stay at certain level of the capital stock, what should be the investment required. Therefore, the investment here indicated by this line is the investment needed to stay at a certain level of the K, but the investment represented by the saving is the actual size of the investment. Because of that, the intersection of the actual size of investment and the required investment to stay at the same level of the K is the K steady state. So this is how we determine the K steady state. And then we know from here, as long as we are given a saving rate and as long as we know what is the steady state condition, then we will be able to determine the capital stock in the steady state. So then how does saving rate affect the economic living standard? In here, we first look at the capital stock in the steady state, and then given that we know the output is a function of the K, so then as long as K is higher, the output is higher. And I will show you why that is the case in this graph. So when we have the capital stock as this level, then we know that the output is at this level in here. So if the economy turns out to have a saving rate that is lower than the original one, we know we can draw a new equilibrium condition, which is in purple. It tells us the investment equal to the new saving, with the new saving rate as plum less than the original saving rate as tilde. and then we find out that in here we have a new capital stock level which is lower than the original one, and in here the implied output is of this level. So on the contrary, if we have a new saving rate which is higher than the original level, then we are going to have a new equilibrium condition, that is the investment equal the S double plum Y. So in here you will notice that once we have a new saving rate, then the capital stock level is now becomes higher because the saving rate is higher. And then we are going to end up have a new output that is higher than the original level, which is here. Therefore, comparing these 3 points, you will notice that when the saving rate is higher, the economy will end up to have a higher capital stock in a steady state, and the corresponding output level should be higher. Therefore, we can conclude in here that given the output is a function of the K, when the K is in a steady state, the output will also be in a steady state. And then when the saving rate is less, then the K steady state is less, so then the output in the steady state is less. On the contrary, if the saving rate is higher, the K steady state is higher, and thus the output in the steady state is higher. So if we want to show this numerically rather than looking at the Solow diagram, let's take a look at the solution for the Solow model, which tells us that the capital stock in the steady state is a function of the S tilde multiplied by A divided by M plus delta, the whole thing to the power of 1 over 1 minus theta. The S tilde is the saving rate, the A is the production efficiency, the N is the population growth rate, the delta is the depreciation rate, and the theta is the capital share. So then from this equation, you will clearly see that because the saving rate is on the numerator, therefore when the saving rate is higher, then the capital stock level is higher. If the saving rate is lower, then the capital stock level should be lower in the steady state. And given that the output is a function of the K, therefore when we plug this K steady state into the production function, then we are going to get the output in the steady state. And for sure, as the K steady state is lower, then the Y steady state is lower. On the contrary, if the K steady state is higher, the Y steady state is higher. Therefore, we can conclude that when the economy has a higher saving rate, it will lead to higher economic living standard. So then here comes another question, that is it always good to increase the saving rate? Because from the previous discussion, we find out that when the saving rate is higher, the capital stock in the steady state will be higher, which implies that the living standard in the long run should be higher. So then does it mean that when we raise the saving rate, we will be able to promote economic growth? But then it comes to an issue of this policy, which is that raising the saving rate is not a sustainable policy for promoting growth. That is because we cannot always increase the saving rate. When the saving rate is 5%, you can increase the saving rate from 5% to 10%. But when the saving rate is 90%, you can increase from 90% to 100%. But then once it hits the 100%, you cannot keep on increasing the saving rate. Therefore, using the policy of raising the saving rate to promote economic growth is not sustainable because there exists an upper bound for the saving rate. The other issue of the saving rate is that when you increase the saving rate, it means that you save, so in other words, you cannot eat. When your saving rate is 100%, it means that you eat nothing. So even though raising the saving rate can raise the output, but it does not necessarily raise the welfare of a nation, because when we are looking at the welfare of nation, we care more about how much people eat. When we are talking about a living standard, it is okay to look at the output per capita. So then when we save 100%, it means that we eat nothing, so it definitely not welfare improving. Therefore, here comes the second issue of raising the saving rate to promote economic growth. It turned out that higher saving rate does not necessarily improve the welfare of nation. And I'll explain why that is so. That is because when we increase the saving rate, even though it can increase the total output, because we know under the Solow model, when the saving rate is higher, the capital stock in the steady state is higher, which implies that the output or income in the long run is higher. If we consume a fixed portion of our income, then when the income is higher, then the consumption is higher. However, when we increase the saving rate, the other side of this behavior is that we need to decrease the consumption. In other words, when we increase the savings, it generates two counter effects on consumptions. One direct effect is that when the saving rate is higher, then the consumption is lower. The second indirect effect is that when the saving rate is higher, the income is higher, so the consumption is higher. Therefore, when we increase the saving rate, we are trading off the dynamic of these two effects. And therefore, in fact, there exists an optimal level of the saving rate that allows us to consume most. So now let's take a look at the Solow diagram to illustrate this concept. So recall, this is the Solow diagram. We have the vertical axis represented by the y, and then given that the investment and the consumption are in the same unit as the output, therefore from the graph, we can also infer the investment and the consumption. In addition to that, we have three lines. The line representing the total output, the line represents the equilibrium of the economy, which is investment equal to the savings. The last line we draw on this graph is the steady state condition. And of course, this graph is drawn based on the model assumption that there is population growth. And so then from here, we know the intersection of the equilibrium condition and the steady state condition will give us the steady state K. So then this is given a level of the saving rate. From this level of the saving rate, we will be able to get the size of investment, which is the distance between these two dots. From the production function, we know the size of the output, which is the output level given the K steady state. So then we already know the size of the total output. We know the size of the investment. So then from the difference of these two, we are going to get the size of the consumption, which is the distance in here. So then we know that when we are given a saving rate, we will be able to infer the K steady state, and then infer the output, and then infer the investment in the steady state, and then we will be able to know the size of the consumption. In other words, if we have another saving rate, for example, if the saving rate now is lower than the previous one, then the steady state of the economy will be at the point where the new equilibrium condition intersect with the steady state condition, and then that will be the size of the K steady state. And then the corresponding size of the consumption is highlighted in purple. On the contrary, we can have another saving rate, which is higher than the original one, and then we will be able to infer the case steady state from the intersection of this new equilibrium condition and the steady state condition, and then we are going to have higher capital start in the steady state. In here, we know that the output is higher. But then it turned out that if we look at the consumptions, it will be smaller than the original consumptions. So then we can notice from this graph, when we move the saving rate from purple to black and then to red, which is increasing the saving rate, we are going to have the consumption changed from purple to black and then to red. As you can see in here, when we increase the saving rate from S tilde plum to S tilde, then the consumption increase. However, when we further increase the saving rate from S tilde to S tilde double prompt, then the consumption in fact doesn't increase even though the output increases. Therefore, from this graph, we obviously observe that when the saving rate is higher, sometimes it will lead to higher consumption, but sometimes it will lead to less consumption. And the reason why that it come up with this result is because when the saving rate increases, there are two forces driving the consumption. One is the direct impact of the higher saving rate that lead to the lower consumption. The other impact is the higher saving rate lead to higher output in the steady state, and thus when the saving rate is fixed, the consumption is higher. So then these two forces interact, sometimes one dominates the other, so then when the saving rate is higher, it does not necessarily lead to higher consumption. So then because of that, the next question that we want to ask that can we find out an optimal level of the saving rate that can maximize our consumption? And it turned out to be the answer is yes. And I will show you that in the following discussion, that is how to come up with the optimal level of the saving rate that maximizes the consumption.